I'm Paolo di Prodi. I'm a senior data scientist for Fortinet, specifically FortiGuard Labs, which is basically a division of Fortinet. And this is a project that I'm doing as a research personal project. So there is no official funding from Fortinet yet. So it's kind of pure open research. It's very experimental. So I basically submitted this talk to get feedback from the audience, and it's really about my personal experience working with large companies and dealing with modeling of cybersecurity events. Okay. As I mentioned, I've been doing a lot of work in data science, and sometimes I feel like a bit of a dual personality. So I do a data science, data mining, go back to machine learning, go back and forward. So I'm kind of a hybrid software/computer engineer. I did a lot of reverse engineering when I was younger, and I'm involved in several projects. So there's the PSS vulnerability prediction system that I guess some people, some of the people in the audience are familiar with, and there's Cyber Threat Alliance, which is basically a collective of companies sharing threat intelligence between themselves. So this is probably the kind of best picture I can find to describe the situation within the cybersecurity environment, where we talk about external threat intelligence. It's that picture is from IBM. It's very structured. Everybody's using Taxi and Sticks. For example, within the Cyber Threat Alliance, we do that quite a lot. So we exchange indicators of compromise, campaigns, and observables. There are issues with that. That it's kind of easy to share, like low-hanging fruits, like in the pyramid of pain is the kind of IOCs, like file hashes. The variety is not that deep for now. So the problems, companies are easy to share information within themselves using these standards. So the problem is really, and I've experienced that many times as I move between different companies doing the same thing, was that internally it's kind of like the Far West, right? That's the spaghetti Western picture from Sergio Leone. But there's like essentially when you go inside, like everybody's using their own stack, different database technologies. Within the same company, there are silos. So like everybody's using their own meta database. They call the same thing different ways. So it's really about how can we sort of find a way to to formalize that process a little bit more, so that we it would be easier to exchange data from inside and outside and vice versa, right? So this is kind of a typical pipeline. I've done a lot of variations of that, and so you have your sensors from IPS, IDS, antivirus, whatever acronyms you have now. You have some sort of transport layer, which hopefully is encrypted, like that. Doesn't always happen. You would be surprised. You have some, not Fortinet, of course, yeah, but you have a lot of packages. You can choose from different formats. NQT, Avro. I mean, these are kind of the newest ones. And then you have a data lake where you put all these, all these logs or events can be centrally distributed. And then you have on the right side where usually I step in is like you have data marts for your business logic. So you want to do threat intelligence analysis, all the cool stuff. And this in practice never really happens so easily. So everything is broken. It's there are silos and policy issues and that kind of problem. But imagine this, in a large company, you might have 100 of these kind of pipelines, and everybody have their own flavors. And when the data lake is more like a data recycling center or data dump, there's a bit of junk and everything inside, and there's no metadata about describing common entities. So when when I go at that stage, everything is a mess, and it's very hard to derive insight from that process. So the kind of solution that I'm still working on, it's not a final product. So I mean, like I don't even have a Docker container yet. So, but you can go and check the code. I think there's a link at the end. It's essentially provide a ready-made schema to users or developers, so that at least you get the basic concept modeled already. So there's a bunch there that you probably are familiar, and not everybody needs everything, but basically model the most common entities that you find in InfoSec. Like the CVE. Today we have done a lot of CVE, CVSS, CWEs, all these concepts. But like there was Mike, which is another standard. Coco is for playbook exchange. MITRE, attack, defend, etc., etc. So and the idea is, you provide the standard schema, and then every company or every group, they can subclass in terms of object-oriented programming, and they can sort of go level ups or level down and say, okay, like this is the base schema, but my company, we have specific subclasses of that entity, so we can take inheritance and create our own device object because we have some specific flags or senior number, for example. And but at least you have a good starting point. So as I was doing that, this August there was a presentation, very nice presentation on Black Hat. And there's I think it was Sophos maybe, or I can't remember which company. It was 2 or 3 companies released this OCSF, which is basically an open cybersecurity framework, and it's basically doing the same thing. But what they don't have is essentially they define a schema, which is JSON, and there are auto limitations with JSON schemas. We can talk about that at the end. But the idea is that they provide you the schema, and they don't give you a reference implementation. So you have to find your ways to create a database and pipeline to store those objects. So in principle, the way it works now is you have I provide an implementation in TypeDB, which is an hyper-connected, strongly typed database. So if you have done OWL and triplets and RDF, cover your ears because you won't like that. But it's basically a normal. You model your entities as a first normalized form in terms of ER modeling, and it's more like a SQL database, but powerful because it's a hypergraph. And so in a typical implementation, there's a video I can launch at the end. All you have to do is essentially define these fields, map them to the schema, and automatically everything ingests into this database. And you can also do okay, that's one of the videos. So okay, somebody's pressing that. So I'll keep talking as you see this. This is basically generating IPS. It's simulating an IPS sensors, like spitting out vulnerabilities. And you can see, like, you can set some parameters. What it's doing, there is like a configuration file that is mapping volume information with CV information. And what the system is doing is saying, well, I have this packet with fields, and I know that this field is a CVE number. So okay, I can create an object in my database. You can see the graph is auto-generating essentially. So it's very simple. The user doesn't have to do anything. So you have the sensor model, the volumes and vulnerability, and because each source had their own authority, each entity, they have their authoritative source. You can auto-enrich the information. So if you have the CVE ID, I know that NVD and MITRE are the sources for that entity. I can expand the attributes in real time. So, okay, let's see. I have more slides. Okay, it's not stopping. Maybe we can stop the. I don't know if they're hearing me. You can stop the video and we can go.
Okay, yeah, we can just let it run.
Right. Okay. So yeah, it's a very simple configuration file. Like you basically define your IPS. In this case, it was an IPS sensor. You can say that's a device. Sorry, that's a datetime. That's a vulnerability entity. That's a count. You subclass this schema, and you just ingest the information with a Python script. So there's more work to be done. So the problem with this JSON schema that obviously it's just been released is that it's not JSON schemas were not really designed to model complex hypergraphs. So there are issues they rely mostly on compositional data models. So there is no inheritance, which it's not very good for type DB because you can do polymorphism and all sorts of constructs. So there's kind of limitations. And what I'm trying to do now, I don't know if it's possible. So I might fail in this attempt is to auto convert the schema to type DB, and then ML will come later. So once the model is finalized, we can do all the cool stuff with graph-based machine learning. There's already a library with PyTorch and other things that can do that. And then basically more tools to to auto-enrich these different entities. Like CVs is kind of easy, but there are like things with KPEC and other entities it's to be hard to do. But yeah, that's what I'm doing, and I think it's 11 minutes, so I can stop and get questions.
All right, I'll turn it on for questions now.
How's this compared to like sticks, Cybox? Like there are already lots of schemas.
Correct. So, okay, I have some appendix, but the Sticks is great. So there's another project that I'm doing based on the same technology. So we are basically implementing the same. We have an OASIS compliant data store for Sticks. What you end up doing with Sticks, and if you want to model all these other concepts like sightings, but like device information, you need to extend Sticks to quite a lot of there's a lot of additions that you have to do into the standard, and you have to then share the schema with other parties. So it basically, like long term, is not a sustainable solution. And Sticks can every 2 years they include new concept into the schema, so it's kind of slow. It's basically not going to work for companies doing that. It's just not feasible for this kind of application. But I've been doing that. Yeah, like this project will be also announced like maybe 1 or 2 months. But yeah, what we discovered is that modeling everything in Sticks, it's not a scalable solution, and companies are not going to use that. But yeah, we can talk after for more details. But very good question.
Okay, we'll take one more back there.
Hi. So I'm from Splunk, and we are pretty big on OCSF. I have my own thoughts on that, but there's not the place for that. So great to see this work, frankly. So I was wondering that as you work towards like broader adoption and comparing to other frameworks like OCSF, are there any trade-offs or limitations that you have in mind which you want to work on, or at least want practitioners to be aware of as they want to adopt this new framework?
Yeah, good question. I mean, like this is kind of a small project for now, but like if there are any like Splunks and other companies that want to be guinea pigs for that, like we can do experiments and see like is it that easy like for Splunk for to adopt this specific approach. And but it's just from my personal experience, I've seen so much problems, failures, and database design, and auto companies like they don't think about analytics until it's too late, and it's just modeling is not their forte. So like they just say, I just care about storing logs, and like if I have to read them, like I have no idea, it's too late at that time. So it's mostly trying to teach people good habits and provide a starting point. And there could be bottlenecks in the future with TypeDB. I'm not sure. It's also kind of a new project. So it's a company based in London, a startup. So it's open source, but it also depends on the specific technology and how it's going to scale up. But they're doing quite well so far. So I don't think that would be a problem. But yeah, it's a longer discussion. We can talk later, but very valid.
Thank you.